In this lecture, we are going to look at the formal charge and exceptions to octet. Now, in our yesterday lecture, we talked about the Lewis dot structures for compound and how to write the Lewis dot structures for various compounds and including molecules and ions. And of course, this class is for the Jupeb and 100 level undergraduate students. So let's dive in to actually talk about what we have for today. However, when I had yesterday's class, after some of you went through the class, there were still some gray areas and some confusion. Now, in this class, we help you to understand better what we mean by some of the things that I was doing there. Now, I took it from the expert view of point. Are you getting? I say expert view of point, expert point of view rather. Like the way I can just look at it and from my understanding, but I discovered that I will have to go as 100 level students in a very slow way so that everybody will understand what the Lewis dot structure is all about. All right. So let's look at the first thing we have here. Now you have write the possible Lewis structure of the nitronium ion. Now, the first thing that you are going to do in this case is to write the formula of the nitronium ion. Now, I didn't write the formula for you because I want you to get acquainted with these ions, these positive ions and negative ions, so that when you see the question just given to you like this, you won't say the structures were not given to you and you'll be able to prepare solution to a question like this. Are you getting that? So the nitronium ion is NO2 positive. This is the complete this is the structure of the NO2 plus, which is the nitronium ion. Now, the next thing we need to do is writing Lewis dot structures follows a number of steps, which I'm going to outline here now. Now, the first step is count the total number of electrons in the structure. Are you getting it? So what we are going to do now is to count the total number of electrons in the structures. Now, note that the electrons that are in the structures like this are the valence electrons, as what we discussed yesterday, in accordance with what we discussed yesterday rather. So the number of valence electron for each of these, which we discussed yesterday. Now, I'm not going to start going through the valence electron chart I gave to you again. You must have started practicing them and then getting acquainted with the number of valence electron for the first 20 elements if possible. So let's go. We have NO2 plus. Now, nitrogen is a group 5 element, so it will have 5 valence electron. All right. Oxygen, let me give it space. Nitrogen is equals to 5 valence electron. Now, oxygen is group 6, and hence oxygen will be having 6 valence electrons. Are you getting it now? But we have 2 oxygens here, so you have to multiply this by 2. Now, 6 times 2 will give us what? 12. Are you getting it now? Now, this plus here, what does this plus mean? The plus means that you have to subtract 1 electron. Are you getting it now? So you now say this positive means what? Minus 1 electron. Plus means it has given out 1 electron. Whenever atoms gives out electrons, you say you introduce a negative charge there. All right. So in this case, you find the total number of electrons here, which is 5 plus 12 is 17. 17 minus 1 is 16. So in this structure, we have 16 valence electron or 16 electron. Now, the next thing we need to do to write the Lewis dot structure after calculating the number of valence electron is to write the skeleton of the structure. Now, the skeleton of the structure talks about how each of the atoms are connected in the structure. Now, writing the skeleton of the structure, I gave you a rule to follow yesterday. Now, the first rule I gave to you was that while writing the skeleton, the least electronegative atom is always the central atom. All right. And then while writing the skeleton also, all you need to do is to use one bond only to link the atoms in the compound or ion given. All right. So the least electronegative atom is usually the central atom. So it means nitrogen is the central atom, and I say you are going to use one bond to link it with the oxygen and then with this other oxygen, since we have 2 oxygen there. All right. Now, having known this, the next step we follow in writing Lewis dot structures is, now recall that to every bond you have like this, there are 2 electrons. All right. To every bond you have like this, there are 2 electrons. So these 2 bonds here, it means there are 2 times 2 electrons, which is what? 4 electrons. So what we are going to do now is to come here. Normally, total number of electrons is what? 16. total electron is 16. Now, any electron you add here, you have to subtract it out. Any bond you have here, subtract the number of electrons. So we added 2 bonds here, remove the number of electrons. So when we remove the number of electrons from the 2 bonds contain 4 electrons according to what I just explained now. So this becomes 16 minus 4. And 16 minus 4 will give us 12 electrons. So it means that we have 12 electrons remaining. So after drawing the skeletal structure, say place 2 electrons in each bond in the skeletal structure. Now we have this bond, we've placed 2 electrons. We know a bond contains 2 electrons. Then the next step is identify the terminal atoms. Now, which of them do you think is the terminal atoms? Anyone that is not the central atom here is the terminal atom. So the 2 oxygens are the terminal atom. The next step is complete the octet of the terminal atom. All right, complete the octet of the terminal atom, paying cognizance to the following. 1, right? Paying cognizance to the following. You should write this. 1, that hydrogen always complete doublet structures and not octet. So whenever you give 2 electrons to hydrogen, it means it has completed its octet. It's doublet. Are you getting it now? Then for the did I say oxygen? Hydrogen rather. Then for oxygen, it has it needs to complete 8 electrons as its octet. The only 2 electrons that have that configuration that you must put 2 electrons to complete the octet are hydrogen and helium, and helium has the 2 electrons already complete, so there's no need. Helium is a noble gas. It doesn't go into this kind of bonding. Is that okay? So complete the octet of the terminal atoms. The terminal atoms here are oxygen. So let's complete the octet by introducing their number of electrons. So this one is already 2 electrons here. You know oxygen also share an electron with nitrogen. So this is already 2 electrons. How many does oxygen need to complete octet? 8, right? So which is 2, this 3, 4, 5, 6, 7, 8. Come here also. 1, 2, 3, 4, 5, 6. Then plus this 2, 7, what? 8. You know here there's an electron here. 7, 8. 7, 8 for this case too. Is that okay? So we've completed the octet of the terminal atom. Now, the terminal atom now took how many electrons to complete the octet, apart from this central one that we actually added here? All right, apart from this one. You know, this one was the initial one. We already subtracted this 4 from the structure, from the number of electrons before now. So now, how many electrons did we use to complete the octet? Or how many electrons rather did we use here to complete the octet? This is 1, 2, 3. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we use 12 electrons. So minus 12 electrons from the 12 electrons here, meaning total number of electrons remaining is 0. So you've spent all the electrons on this structure. Now, this is the Lewis structure, or let's just say this is the skeletal way of writing the nitronium ion. Now, the next thing is subtract the number of electrons used to the point, to this point. That means at this particular point now, which I've already done, subtract it from the one that was remaining, which is 12 minus 12, give us 0. Now, if there were still more electrons remaining, you add it as a lone pair of electron on top of nitrogen here. All right, but since there is none, all you need to do is leave it. Now, the next thing we need to look at is the octet of nitrogen. Is it correct? Now, this is a bond. A bond is 2 electrons. So we have 2 electrons, 2 electrons, which is how many? 4. And nitrogen normally need to have 8. So what we are going to do in that case is promote 1 electron from here to this place. Promote 1 electron from here to this place in such a way that there will be a bond between these, and this will give us something like this, double bond. If you promote these 2 electrons here, miss a bond. Is that okay? Because I said 2 electrons miss a bond. So this becomes a double bond, oxygen, and then you have your remaining lone pairs of electrons. Remember that there were initially 1, 2, 3 lone pairs, but if you take 1 here, this gives us 2 lone pairs remaining here. So also here, if you take 1 here, this gives us 2 lone pairs remaining here. So the question now is the octet of nitrogen complete? And every other atom here, is the octet complete? Now look at nitrogen. Nitrogen is how many here? This is 2 electrons here, because each bond have 2 electrons. 2, 4, 6, 8, which is complete. How about oxygen? This is 2, 4, this 6, 8 is complete. Same thing applicable to this one. 2, 4, 6, 8. Everything is complete. So this is the correct Lewis dot structure for this compound. Now you have to introduce the positive sign on top of nitrogen here. All right. So this is the correct Lewis dot structure of this compound. Now when we talk about the idea of formal charge, you know why this one is the most stable Lewis dot structure. Is that okay? Now let's draw for another compound quickly. You have Hydria Xenium Ion. Draw the Lewis dot structure for Hydria Xenium Ion. Now Hydria Xenium Ion is N2H5 positive. So N2H5 positive. Now what we are going to do is first of all draw the skeletal structure. Now to draw the skeletal structure, we say on no account should hydrogen be the central atom. Is that okay? On no account should hydrogen be the central atom. Is that okay? So what we are going to do now is put nitrogen here. Then one of these nitrogen have to lead to the other nitrogen, because we said the hydrogen must not be the central atom. Is that okay? Then we have to distribute the hydrogen among these nitrogens. Now this is the rough sketch of it. Let one hydrogen come here, another hydrogen come here, another hydrogen come here. The four corners of hydrogen is already completed here. Are you getting it now? So once the four corners of hydrogens are completed, you come to the next one. This is 1 and this is what? 2. So in total how many are here? 1, 2, 3, 4, 5. It's now complete. So this is the skeletal structure of it. Now we are now going to count the total number of electrons first. Even before this one, we are supposed to count the total number of electrons. Now nitrogen is group 5 elements. It has 5 valence electrons. How many nitrogen are there? 2. So this becomes 2 times 5, which gives us 2 electrons for nitrogen. It's how many? 1 hydrogen. So we have 5 hydrogens. Now hydrogen is group 1 because it has 1 valence electron, but it's not group 1, but it's considered as a group 1 while you are writing the Lewis dot structures. All right. So this is 1, and then you have 1 times how many hydrogens are here? 5. So this becomes 1 times 5 is 5 electrons. Now this plus here means subtract 1 electron from the sum. So subtract 1. So this 10 plus 5 is 15, minus 1 is 14. So total here we have 14 electrons. All right. So what we are going to do now is we've already brought out the structure, the way the structure is supposed to be. Is that okay? Now having brought out the structures, now the next thing you need to do now is to count. You know, for the structures you use a bond to join each of them together. So let us count the total bonds here that are present. This is 1, 2, 3, 4, 5, 6. Is that okay? So in this structure you already have 6 bonds. Now 6 bonds, total number of electrons is 14 electrons. Now 6 bonds has 12 electrons, right? So this becomes 14 minus 12, which is 2 electrons remaining. Is that okay? Now you are now going to look the octet of hydrogens, which is the terminal atom, because after writing the structure like this, you need to look at the terminal atom and then balance its doublet or octet. Now in the case of hydrogen, it's already balanced because hydrogen just needs 2 electrons, right? Which every bond here gives hydrogen 2 electrons, 2 electrons, 2 electrons, 2 electrons, 2 electrons. Now the next thing we need to do here is that we are told that we have to add the remaining 2 electrons to the central atom. Is that okay? So we add the remaining 2 electrons to the central atom. So in that case, let's take this one as the central atom here, which could either be this nitrogen or this nitrogen. But we are going to take this one that have space. So we are going to add the 2 electrons here. Is that okay? Now having added the 2 electrons, you have a positive charge here. Where will the positive charge be? Now, according to what I told you yesterday, I said the positive charge can be outside here. All right? But it can also be on top of the central atom. Now, it can also be on top of the central atom. But my question now is, which of the central atom is it going to be on top? Is it this nitrogen or this nitrogen? Now, you have to count the number of bonds around each of the nitrogen to ascertain which one it will be around. Now, if you look, this is 1, 2, 3. 3 bonds, right? Now, count normally how many hydrogens, how many electrons does nitrogen is bringing to the table. How many is it bringing to the table on a normal basis? Are you getting it? On a normal basis, nitrogen is supposed to bring 5 electrons to the table. When I mean to the table, it means 5 electrons is what it's supposed to contribute. But if you look at this structure very well, that is what I'm going to explain in the case of formal charge and the rest. But let's just take a periphery of it, or just look at the surface here first. Now, what I mean by how many electrons is nitrogen bringing? The number of electrons that nitrogen is bringing is equal to number of electrons it is bringing. We can say is the number of lone pairs of electron, right? Plus half of the bond pairs. Are you getting it now? Number of lone pairs plus half of bond pair. So this nitrogen, now let us count. How many lone pairs is here? Is 1. So this is lone pair electrons, not the number of lone pair, but the lone pairs electron, number of lone pairs electron. So how many lone pair does it have here? 1. How many lone pairs electrons are here? Is 2 lone pair electrons. So you write 2 plus. Now, how many bond pairs electrons are here? 1, 2, 3. 3 is 6. 6 divided by 2 is what? Is 3. Are you getting it now? So it's half of the number of bond pair electron. Now, bond pair electron means the electron that is sharing with every other atom. Now, if you look at this, there are 2 electrons here, which is making this one to be 2, 3. I mean 2 plus another 2 here, 4 plus another 2 here, making it what? 6. So it means it is having 6 bond pairs electrons. So we say times 6. If this divide by this is how many? 3. So you have 2 plus 3, and 2 plus 3 is going to give us 5. So it means nitrogen is bringing 5 electrons to the table. Now, if the number of electrons it is bringing to the table does not correspond to the number of valency, then you mean that a particular charge is present there. And we can find the charge by saying it is the number of electrons it's supposed to bring, which is the valence electron. Are you getting it? Let's say it's the valence electron minus the number of electrons that is in the bond, or that is in the Lewis structure. The valence electron minus number of electrons in the Lewis structure. Valence minus number in what? Lewis structure. Let me take it that way. I'm already teaching formal charge, which I'm not supposed to teach, but let me just do it. So we say the number of electrons that this nitrogen we have, or where we are going to put the positive charge now is what we are looking for. Is that not so? We say to get where the positive charge will enter, subtract the number of valence electron normally minus the number of electron in Lewis structure. In the Lewis structure. Now we already calculate the number of electron in Lewis structure as equals to the lone pairs of electrons in the Lewis structure plus half of the bond pair in the Lewis structure. Is that okay? So in this case now, number of valence electron for this first nitrogen we calculated for is 5. So we'll now say this becomes 5 minus the number of electrons that we calculated from the Lewis structure is also 5. So 5 minus 5 is what? 0. Now what this is telling us that this nitrogen does not have any charge in it. So let us go to this nitrogen to see if this one is the one that will carry the positive charge. Is that okay? Now what we are going to do is now calculate the number of electrons in the Lewis structures of this compound. Is that okay? In the Lewis structure around this nitrogen rather. So number of electrons will be equals to lone pair. Is there any lone pair on this nitrogen? No. So this gives us, I can erase this. Number of lone pair is what? 0 plus half of the number of bond pairs electron. Now this is one bond pair which contains 2 electrons. So this is 2, 4, 6, 8 times 8, which equals to half of 8 is what? 4 plus 0 is what? 4. So we are now going to say that where the charge will now be number of valence. Number of valence is what? Normally 5 minus the number of electrons in the Lewis structure. Number of electrons we have is what? 4. 5 minus 4 is what? Plus 1. Is that okay? So it means that this nitrogen will be the one to carry the positive sign, and then this positive sign it carries must be equal to the charge on this outside here. Is that okay? So instead of putting the charge outside here, in some cases you can put it here on this thing. So the structure can be written in two ways. Let me just make it more matured. Structure can be written in this way, and also it can be written in this way: hydrogen, nitrogen, hydrogen with the two lone pairs of electron. Then we have nitrogen, hydrogen, 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 and then positive charge. So if you are not introducing the bracket, you don't need to put the positive charge on top here. You just need to put it on top of the correct nitrogen. All right, so this is the correct Lewis dot structure for this compound. Now just progress with the lecture. This one looks a little bit confusing. Now as time goes on, you understand better what I want to do. Orderliness matters a lot. Let's order this particular one we are going to do next. Now you have write the possible Lewis structure of hydroxyl ammonium ion. Now hydroxyl ammonium ion is something like this: NH3OH positive. All right, hydroxyl ammonium ion is NH3OH positive. Now the question now is, which of them will be the central atom? We said, or basically first, the first step is calculate the number of electrons. Now nitrogen is group 5. How many nitrogen are here? 1. So 5 times 1 will give us 5 electrons for nitrogen. Hydrogen is group 1 also. It has 3. There are 4 hydrogens here. So 1 times 4 will give us 4 electrons. Now oxygen is group 6. It has 6 electrons. 6 times 1 will give us 6 electrons also. So I think we've calculated all. Now this positive here means subtract 1 electron from here. All right, which will be equal to 5 plus this 4 plus 6 is 10 plus 5 is minus 1 sum. Now 4 plus 6 is 10 plus this is 5 minus 1 is 14 electrons. All right, now have we gotten 14 electrons? The next thing is to draw the skeletal structure between nitrogen, hydrogen, and oxygen. Which do you think? Of course, we said hydrogen cannot be the central atom, so that is out. So between nitrogen and oxygen, which is more electronegative? Oxygen is more electronegative, and we said the least should be the central atom, so it means nitrogen will be the central atom. Now if nitrogen be the central atom, we have to draw the structures in such a way that you have all the hydrogen in 4 corners of this structure. Are you getting it now? So you have hydrogen, hydrogen, hydrogen. Then you are going to have this oxygen now will be the one that bonds this hydrogen like this. All right, that is why they are together, OH. Is that okay? So you have the hydrogen, 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 and then O and hydrogen. If you look at what we already did initially, I told you, or we can actually make sense by saying that since nitrogen is the least electronegative, then we follow by the one that is next, oxygen. Then you now start attaching the other external atom, which of course in this case is hydrogen. So what we are going to do now is count the number of bonds already, number of electrons in the bonds already. 2 electrons make 1 bond. So this gives us 2 electrons, 2, 4, 6, right? 8, 10. We've already utilized 10 electrons. So total is 14 electron. Number that is utilized is what? 10 electron. 14 minus 10 is 4 electrons. So we have 4 electrons remaining. Is that okay? Now, since we have 4 electrons remaining, what did I tell you? I said you look at the octet and see if the octets of the atom attached, apart from the central atom, are complete. Now, hydrogen is doublet. Wherever you see 1 bond in hydrogen, know that it's complete because it only needs 2 electrons in its outermost shell. Is that okay? So in this case, we can say that hydrogen is complete, but oxygen is incomplete. No, oxygen is group 6, right? And hence, it will need 8 electrons in its outermost shell, which is octet. So you should make sure that all the electrons fills up to 8. Is that okay? So this is already 2 electrons, 4, because each bond is 2 electrons. 2, 4, then here is what? 5, 6, 7, 8. So we've already filled in 4 now. Now, 4 minus 4 that we just filled in now, making it what? 0. So it means that there is no other electron remaining. Is that okay? And since there is no other electron remaining, now where are we going to put the what is it called? The positive charge. Now note something, that whenever nitrogen form bonds, just know that nitrogen has the positive charge. Look at this one, form 1, 2, 3, 4. Even the one we did earlier, it also formed 4 bonds. 1, 2, 3, 4. We say the positive charge should be here. Is that okay? So in this case, the positive charge is for nitrogen. I will calculate it by saying number of valence electron for nitrogen is what? 5 minus half of lone pairs. How many lone pairs is here? None. Then times bond pairs. Is there any bond pair here? Yeah, there are 1, 2, 3, 4. Each pair is 2 electrons, so the bond pairs electron will be how many? 8. So this divided by this, which is 4. 5 minus 4 is plus 1, and this gives us plus 1 on top of here. So this is the correct Lewis dot structure of the hydroxyl ammonium ion. Is that okay? So that is that. Now we have the next one, the bromate ion. Now bromate ion, I've drawn it yesterday before, but I just want you to use this ideology now to draw it. Now bromine is group 7 element. It has 7 valence electrons, and we have 1 bromine here, so 7 times 1 will give us 7 electrons. Oxygen is group 6, and it has 6 valence electrons. We have 3 oxygens there. 6 times 3 is 18 electrons. Now this minus here, it means you should add 1 more electron to this. So adding plus 1 more electron, this will give us 7 plus 18 is 25, plus 1 is 26 electrons. So total number of electrons we are supposed to form here is 26. Now bromate ion, the structure will be Br. We have oxygen. This is skeletal structure. Now what we are to do next is the bonds we have here, subtract the number of electrons from the ones we have here. So the bonds are 1, 2, 3, which is 3 times 2, because each bond is 2 electrons. 3 times 2 is what? 6. So we can now come here and say total 26. Each of these 3 bonds, total of the 3 bonds is 6 electrons. So 26 minus 6 is 20 electrons. So it means we have 20 electrons remaining. Now the next step is complete the octet of the terminal atoms. That means the atoms that are attached. So quickly now, everybody can do this. This gives us 1, 2, 3, 4, 5, 6, plus these 2 here, 8. 1, 2, 3, 4, 5, 6, plus these 2 here, 8. 1, 2, 3, 4, 5, 6. Are you getting it? Plus these 2 here, 8. So if you count, this is 6, 6, 6. So it means we've subtracted the total of 6 times 3 is what? 18. So it means we've removed 18 electrons from this 20 that is remaining. So we are left with how many electrons? 2 electrons. Now any electron that is remaining after completing the octet of the terminal atom should be added to the central atom as a lone pair of electrons. So we have 2 electrons remaining. These 2 electrons will come here as lone pair. So this is the Lewis dot structure of what is it called? Of the bromate ion. Now, but the way it is here, is it actually complete? Is it complete? Now, this is where I want to teach you something. That this structure, the way it is here, it is not complete, and this is not the correct Lewis dot structure. Because you don't know where that minus, you don't know where the minus is coming from, or the minus will be. Are you getting it now? This negative charge, you don't know where it will be. Now, how do we know where the negative charge will be? Is the idea of formal charges. But I told you that instead of going to learn about formal charge and confusing yourself, this is what you are expected to do. Recall that the ones that we'll be doing is that the most stable one is the one in which the charge around the central atom is always what? 0. Is that okay? The one in which the charge around the central atom is what? 0. Now, bromine is the central atom. So the charge around bromine, we should do it in such a way that it will be what? 0. Now, the question is, how many electrons does bromine have? 7. And you know that to get 0 in the middle, it means the valence electron, right? The valence electron must be equal to the number of electrons in the Lewis structure. Are you getting it? That the central atom brought to the table. Is that okay? The valence electron must be equal to, because if they are equal, you recall that what we did initially was to subtract. So if they are equal, if here is 7, it will be 7 minus 7, which is what? 0. Do you get it now? So it means that the central atom should have a charge of 0. That structure is the one that is more complete. Are you getting it now? And that is usually possible in case when you want to do double bonds and whatever. That is what you should be looking up to. So in the case of this bromine, you already have, let's calculate the total number of electrons in the Lewis structure. The valence electron is 7. So we should manipulate this structure until we have the total number of electrons that will be equals to 7 in such a way that this charge now will not be what? 0. So let's calculate. Now to get the number of electrons in the Lewis dot structure, what we do is say we add the lone pairs of electrons. How many lone pairs here? 1, and it's 2 electrons. So we have 2 electrons from the lone pair plus the bond pair is how many? 1, 2, 3. We say half of the total number of electrons for the bond pair, which is half of, if this is 1, 2, 3. 2 times 3 is what? 6, because every bond is 2 electrons. So this gives us 6. This divided by this is 3. 2 plus 3 is what? 5. Is that okay? Now this 5, what is it telling us? It tells us that bromine, we need more 2 electrons. Are you getting it? In order for this compound to be very stable, and that will give us the correct resonance form and the correct Lewis structure for this compound. Now how do we do that? It's very easy. It means that this bromine here, if you even do it, this becomes 7 minus 2. 7 minus 2 is what? Is plus 7 minus 5 rather, right? Is plus 2. It means that this bromine is having, in this structure now, is having a charge of plus 2. That's what it's telling us. True or false? Because we said to get the charge that is present there to be the number of valence electron minus the number of electrons attributed from the Lewis structure. Is that okay? So 7 minus 2 is what? Plus 2. But the one that is most stable is the one that this charge is 0. Bromine is 0. So we are going to draw another structure now. Now the other structure will be such a way, if you donate 1 electron from here, if you donate the 2 electrons, you know this electron, if it is coming, one will be for bromine and the other one will be for what? Oxygen. So if you are donating 2 electrons here, it means it's only one that you are donating to bromine and the other one will also be for oxygen. So the charge here will return to what? Plus 2. Plus 1 rather. So this gives us something like this. B arrow. Here is oxygen. Here we come a double bond. Here is oxygen. And then we have here will be 1 and then 2, because you've used this one to form a double bond here. And then here is 1, 2, 3, 4, 5, 6. And then here is also 1, 2, 3, 4, 5, 6. Now calculate the total number of electrons in this Lewis structure for this. There you have the 2 lone pairs of electrons also here. So what we are going to do now is to calculate for bromine the number of electrons in the Lewis structure. Now lone pairs of electrons are how many? 2 plus bond pair now is how many? 1, 2, 3, 4. So we have 4 bond pair, and we say it's half of bond pair. Bond pair is 4. Are you getting it? Which is 1, 2. This double bond is 2 here. 4. Now each double bond is 2 electrons, which is 2 times 4, which is making it what? 4 here. I mean 8. So this cancel this. This gives us 4. 2 plus 4 is how many? 6. So it means that in this particular structure now, there are 6 electrons in the Lewis structure. But we said the one that we need is the one that there are exactly 7 electrons, so that the charge in this central atom will be what? 0. So let's continue. So for this one, it is 6. Let me come here, right? For this one is 5. This one is what? 6. Now, this one that is 6 now, what do you think will be the charge here? We say the charge is the number of valence electron minus the number of electrons in the Lewis. Number of valence electron is what? 7. Minus number of electrons in the Lewis is what? 6. 7 minus 6 is what? Plus 1. Alright? So this will be +1 charge here. All right, but we need the one that the charge is 0. Is that okay? Now we can take this bond here, this lone pair here, and form another double bond here. Is that okay? So this will give us a new Lewis structure, which is something like this. We have bromine, then we have double bond oxygen, and then of course you have the lone pair of electron. Here it becomes 2 because it has used 1 to form a double bond. Here is still remaining 1, 2, 3, 4, 5, 6, and here is 2. All right, then we have the lone pair of electron here. Now in this structure, what is the formal charge now? What is the charge on this bromine? The charge is number of valence electron in the Lewis structure minus the valence electron. So let us calculate number of valence electron in this Lewis structure. All right, so let's calculate the charge on this bromine now. In this case, first of all, let us calculate the number of electrons in the Lewis structure. We said is the valence electron, lone pair of electron here, which is 2, plus there are 2 lone pair electron, because there is 1 lone pair here and there are 2 electrons. Now these bond pairs, we said half of the bond pairs. Bond pair is 1, 2, 3, 4, 5. Is that okay? Which is 5 times 2, because every bond pair you see here is, are you getting it? Which is 10. So this cancel this, and this gives us 5. 2 plus 5 is 7 electrons. So you see that in this case we have 7 valence electron for this 7 electrons in the Lewis structure of this last structure you have here, and 7 minus 7 will give us 0. So it's that the formal charge of bromine here is what? Is 0. Is that okay? Now this structure you are seeing here now is the right Lewis structure, is the correct Lewis structure for this compound. All right, and then you have 2 minus here. This is the correct Lewis structure of this compound. Please take note of it, not the other 2 upwards. And why is it so? That brings us to the idea of formal charge, because I explained this to you yesterday, but most of you were not really getting it very well. Now that brings us to the idea of formal charge. Now what is formal charge? Formal charge are apparent charges on certain atoms in the Lewis structures that arise when atoms have not contributed equal number of electrons to the covalent bond joining them. When they've not contributed equal number of electrons to the covalent bond joining them, that is when the formal charge occur. Now if you look at this structure very well, you see that the charge on bromine is how many? Is 2. Are you getting it now? But bromine has not contributed the number of electrons he brought equally here. Bromine brought how many electrons? 7. Is that okay? But if you count, now you know that every bond you see here, one of the electrons is for oxygen and one is for what? Bromine. Are you getting it now? We know that when we calculated, the number of electrons for bromine in this structure was 5, and whereas it brought 7, so it has not contributed up to the number it brought. Is that okay? It has not contributed up to the number it actually brought, so you have to bring the charge in here. Now normally this other one here is 6. It has a formal charge of 1. Now how many electrons was bromine supposed to have? 7. It didn't contribute up to that 7. Is that okay? Now how about this one here? If you look at this structure, when we did it, it has 7 electrons, so it means bromine in this structure contributed 7. Is that okay? So that is that. Now to calculate this formal charge, we say is the number of valence electron in free atom minus the number of lone pairs of electrons minus half bond pairs of electron. Is that okay? Or we can say the formal charge, according to the formula I gave to you before now, is equal to the number of valence electron of free atom, that means before it came into bonding, of free atom minus the number of electrons in Lewis structure. in Lewis structure. All right, minus the number of electrons in the Lewis structure. I believe that is that for that particular one. And the most the Lewis structure that is more, or let's say the structure that is more stable, is the one that the formal charge is minimal. Is that okay? Is minimal. Now, we said the formal charge can also be calculated using the formula number of valence electron in a free atom minus the number of lone pairs of electron minus half of bond pairs of electrons. These two formulas are the same. Is that okay? Formal charge is the number of valence electrons in the free atom minus number of lone pairs of electron minus half bond pairs of electrons. So, let's come here. Say the following rules are general rules that can help to determine the plausibility of a Lewis structure based on its formal charge. When you say plausibility, it means the possibility. Are you getting it? To determine the reasonable structure, plausible, the reasonable structure that is supposed to be formed. Now, take the points down. They say, first one, the sum of the formal charge in a Lewis structure must be equal to 0 for a neutral molecule. The sum of all the formal charges in a Lewis structure must be equal to 0 for a neutral atom and must be equal to the magnitude of the charge for a polyatomic ion. So if I should give you a neutral atom, let's say ACN, all the formal charge must be equal to 0. But if I should give you something like this, it means the formal charges should be equal to what? Plus 1. Are you getting? Take note of this. Where formal charges are required, they should be as small as possible. So if formal charge is present, they should be as small as what? Possible. If you have atoms that have a formal charge of plus 2 and you have another one that have a formal charge of plus 1, or let's say an ion that have a formal charge of plus 2 and another one that have a formal charge of plus 1 should be taken as compared to plus 2. Now, negative formal charges always occur on the most electronegative atoms. Positive formal charges on the least electronegative atoms. It is unlikely for adjacent atoms to have formal charges of the same sign. Are you getting it? It is very, very unlikely. Now, let's look at a question here. This question, we are going to spend time with it. The question says, write the plausible Lewis structure of nitroc chloride, one of the oxidizing agents present in aqua regia. Now, aqua regia is a mixture of concentrated nitric acid and hydrochloric acid that is capable of dissolving gold. Are you getting it now? That's what aqua regia is. A mixture of what? Nitric acid, mixture of HNO3 and HCl is called aqua regia. All right, it is we are not talking about inorganic chemistry now, so I'm not going to dive into details on aqua regia. All right, so you were asked to draw the possible Lewis dot structure of NOCl. So we are going to write NOCl now. First of all, write everything we need to know about the Lewis structure. Now, the first step I told you, calculate number of electrons, valence electron. Nitrogen is 5. There is 1 nitrogen there times 2. This will give us 5. Oxygen is what? 6. There is 1 oxygen there, which will give us 6. Chlorine is 7. There is 1 chlorine there. So we have 7 times 1, which will give us 7. So in total now, we have 5 plus 6 plus 7. 5 plus 6 is 11. Plus 7 is what? 18. So we have 18 electrons in total. Now the next thing is to bring out the structure NOCl. Now, which of them do you think will be the skeleton? How will the skeleton be? Which of them do you think will be the central atom? Now, in the periodic table, oxygen and chlorine are in the same, they have the same valence electrons in the periodic table. Are you getting it? They have what? The same valence electron in the periodic table. I say valence electron, sorry. Oxygen and chlorine have the same electronegativity in the periodic. I'll be nitrogen and chlorine, something like that. Let me check. I know one of them among those two. Nitrogen, no, this periodic table. I'm looking for a table of valence electron, of electronegativity rather. Nitrogen is 3.0. Chlorine is what? 3.0. Oxygen is 3.5. So you see that nitrogen and oxygen have the same number of valence electron. All right? I mean, oh God. Why am I calling valence electron? They have the same electronegativity value. All right. Now, so what we are going to do is come here, write it means that nitrogen can be the central atom and chlorine can also be the central atom. So the structure can be in this form: to oxygen, to chlorine, or you can have it as chlorine being in the middle, bonded to oxygen and nitrogen. Any of these structures are correct, or any of these skeletal structures are very, very correct. All right. So now, having gotten this structure like this, the next thing we need to do now is to introduce the former charges, or to introduce the concept of writing Lewis dot structures from what we learned. We say when we see structure like this, what do? Count the bond first that are linked them together and then subtract it from the total number. So total number of bond here is how many? Let me give a small listing here, small box. Total number of bond here is how many? 18. Total number of electron rather 18 minus bond here is how many? 2. 2 times 2 is what? 4. You should not be asking me where I got the other 2 I multiplied it by, because we said every bond here has 2 electrons. So 4 electrons, making this a total of what? 14 electrons. Now, have we got to 14 electrons left? The next step says you should complete the octet of the terminal atoms. So let's complete this. 1, 2, 3, 4, 5, 6 plus this 8. 1, 2, 3, 4, 5, 6 plus this 8. 1, 2, 3, 4, 5, 6 plus this 8. 1, 2, 3, 4, 5, 6 plus this what? 8. All right. Now, look at nitrogen very well, and then let's calculate. Look at nitrogen very well. You agree with me? Or first of all, how many are here? 1, 2, 3, 4, 5, 6, 8. 6 first, 6 here, which is we've removed 6 times 6. 6 plus 6 is how many? 12. So we've removed 12 here. So total how many is left? 2 electrons. Then you have to put the 2 electrons here. Is that okay? Now that we've included the 2 electrons there, which should be the electrons remaining, we say after calculating for the terminal octet and see that they are complete, add whatever that is remaining to the central atom. Now that we have done that, the next thing we need to do is see if the valency of nitrogen is complete and if the former charge on the nitrogen is what? Complete. If the former charge on the nitrogen is 0, it means that every other one there has that particular former charge of 0 also. So let's calculate for that of nitrogen. Nitrogen has 5 valence electrons normally. Now to calculate for the charge that is present here, what we are going to do, first of all, let's calculate for the bond here. Are you getting it? The bond, the number of electrons in the Lewis structure. We say number of electrons in the Lewis structure is the lone pair. Lone pair of electron here is 2 plus half of the bond pair. Bond pair is 2. 2 times 2 is what? 4. You know where the other 2 is coming from. This multiplied by this is what? 2. 2 plus 2 is how many? 4. So this is 4. 5 minus 4 is what? 1. So it means that in this structure like this, nitrogen is what? Plus 1. But our structure given to us does not have any charge. Is that okay? Since our structure here does not have any charge, what we are going to do now is to make sure that nitrogen loses this plus 1. And to do that, we have to just donate this lone pair of electron to this double bond here. All right? We donate the lone pair of electron to the double bond. So if we donate that lone pair there, what will it now become? The new structure will be now Cl, nitrogen, double bond, oxygen. We'll have the 2 lone pair. Then this will also have whatever that we have here. All right, and then with this will have this 2 will be remaining because you've carried this one here. All right, so in total now nitrogen has 5 valence electron minus. Now let's calculate number of electrons in this Lewis structure to be lone pair of electron, which is 2 plus half of bond pair. Bond pair is 1, 2, 3, 4. All right, is that okay? Bond pair is it 4? Yeah, this is 1. This is 1 bond pair. 2, 3, 4. 4 times 2 is what? 8. So 2. This is 2. 2 cancel 8. This is 4. 4 plus 2 is what? 6. So 5 minus 6 is what? Minus 1. It means that in this structure, this one has a charge of minus 1, which is not so because the compound given to you is a neutral compound. So the Lewis structure must be also neutral. Are you getting it now? Now the next one we are going to do is take this one. Did I just calculate? Wait, this is 1. Okay, let's continue. So if we bring this one here, this will form a double bond here. And then we have 2 more electrons remaining, 2 more lone pairs. Here you also have this. Are you getting it now? So that at the end of the day now, what are we going to have? This gives us lone pair of electron is 2 plus this now is sorry. I know that we are missing something. This structure is actually very correct. All right, so please take notes when you are taking this lecture. Take note of this place, because this is 2 electrons plus 2 lone pairs, right? Plus half. This is 1, 2, 3, which is what? 2 times 3 is 6. Is that okay? Which is times 6. This divided by this is what? Is 3. 2 plus 3 is 5. 5 minus 5 is what? 0. All right, so it means that this structure here has the nitrogen here has a formal charge of 0, and the formal charge we have here is what? 0. So this is the correct Lewis structure of this compound. All right, this is the correct Lewis structure of this compound. Is that okay? So that is the idea of formal charge, correct Lewis structure of this compound. Now if you calculate for the formal charge of chlorine here, you can calculate for the formal charge of chlorine here. Formal charge of chlorine here will be in this particular one. Now let's calculate for the formal charge of chlorine and that of oxygen, because the one we'll be calculating for is that of the central atom. Once the central atom's formal charge is somehow 0, it means that every other atom will be 0 for a neutral atom. All right, so let's calculate for that of chlorine. Now valence electron of chlorine is 7. How many electrons does chlorine bring into this thing? Does it have lone pair? It has 1, 2, 3. Are you getting it now? So it has 6 lone pairs, because every lone pair is 6 electrons. So this becomes minus 6 times half of the bond pair. Now bond pair is the number of electrons that it's used to bond with this nitrogen. How many bond pairs are here? Just 1. Each bond pair has 2 electrons. So this gives us times 2. This cancel this. This will give us 1. So this gives us 7 minus 6 times 1. Now 7 minus 6 times 1 is what? Sorry. This is supposed to be plus here. 6 plus half of this. So this becomes plus 1. 6 plus 1 is 7. 7 minus this is what? Is 0. Alright? So that is the correct answer for this one. Now how about that of oxygen? Oxygen now, formal charge would be, how many electrons did oxygen bring into this thing? How many lone pairs of electrons does oxygen have? 6 minus, now lone pairs of oxygen is 1, 2, so we have 4 electrons for the lone pair, plus half of the bond pairs is how many? 1, 2. It has 2 bond pairs, which is 4 electrons, right? This cancel, this is 2, so we have 6 minus 4. 1 times 2 is what? 2. So this is what? 6. 4 times this is what? Is 4 plus 2 is what? 6. This is 6 minus 6 is 0. Now you should always remember to put this in bracket. I don't want to do it in step like 6 minus this. That's why I just did it in one step here. So you see that all of them have formal charge of 0. So for every neutral atom, you have neutral compound, their formal charges must be equal to 0. Is that okay? So that's how to calculate formal charge. And the one that is more stable is the one that the formal charge is equal to the formal charge in the molecule. In this case, equal to the charge on the molecule. This molecule is 0, so the formal charge must be 0. Total of the formal charges, everything here is 0, 0, 0. Is that okay? So this is the correct Lewis structure for this compound. And if you could remember what I told you, you know, while I was teaching you this, I just gave you the understanding once. But some of you, I still wanted you to know why why we have to go through all those stages. Now, if you remember what I told you, I said I haven't known the central atom. Note the number of electrons that each of the atoms will be needing. We said in this case, now oxygen will be needing how many electrons? 2, according to what I taught you before. So what you do is put 2 electrons here, right? Now chlorine will be needing how many? 1, because chlorine is group 7. It needs 1 electron to complete its atomos. Put 1 electron here. So this oxygen now, since oxygen is needing 2 electrons, according to what I told you in the last lecture, that oxygen will also bring 2 more electrons, which is 1, 2, then we have 3, 4, 5, 6. And then chlorine is needing 1 electron, so it will also bring 1, which is 1, 2, 3, 4, 5, 6, 7. Since chlorine has 7 valence electron. And then this will give us the structure. So the structure would be, however, that of nitrogen, we also have 2 electrons here, because we said we use 1, 2 to bond with oxygen, you use 1 to bond with chlorine, then it also remain 2 electrons, because nitrogen is 5. If you use 2 to bond with, you use 1 to bond with, that is 3, plus this 2 here, making it 5. So this gives us nitrogen, double bond oxygen, this chlorine, then we'll have this. This was what I taught you yesterday, because I don't want you to undergo through the stress of calculating for formal charges. And this is the easiest way of knowing how to draw Lewis structures. Is that okay? But everything I'm still teaching you now is to build upon the knowledge that you have before. Alright? Now, let's do more examples. Do I still have more examples here? Now, we have, you say, using the formal charge is to write Lewis structure. Write the most plausible Lewis structure of sulfur dioxide and sulfur trioxide. Now, I haven't written this. What you are going to do for me as an assignment here, this one, okay, I will do it after now. I will write the assignment. Say, write the plausible Lewis structure of sulfur dioxide. Sulfur dioxide structure of S is SO2. And then sulfur trioxide. Sulfur trioxide is SO3. What is the best Lewis structure for this? Now, first of all, follow the normal step. Calculate number of electrons. Sulfur is group 6, so it has 6 valence electron, right? So we come here and say sulfur, that's 6 valence electron. 1 sulfur is there, so we have 6 electrons for sulfur here. Oxygen is also group 6, so it has 6 valence electron. There are 2 oxygens here. 6 times 2 is 12 electrons. All right. Now, have we gotten this? We have to take a careful look at it. Is there any other thing we need to add here? No, there's no charge, so we don't need to add or subtract. So add everything here together, which gives us 18 electron. So we come here and write total electron, 18 electron. Now, what will be the scalency? Sulfur is less electronegative than oxygen. Of course, I told you that the one that will be the central atom is usually the one that is not carrying any subscript. So sulfur will be the central atom, and then to bond with what? Oxygen. 2 oxygen, because there are 2 oxygens there. Now, according to what I told you, the next thing is subtract the number of electrons that you already used to bond. So you use 2 bonds here, which is 4 electrons. So subtract 4 electrons. So minus 4 electrons, total of what? 14 electrons will be remaining. Now, complete the octet for the terminal atom. So this gives us the octet for the terminal atom. This will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Plus this one, 8. 6 plus this one, 8. Are you getting it now? So we now use 6, 6 to make it how many now? 12 electrons that we've removed from here again. So this minus 12 electrons. 12 electrons minus this. 2 electrons will be remaining. Now we say the 2 electrons, you add it here as lone pairs of electrons. But you have to look at this sulfur. Is the valency of sulfur complete? No. Now, since the valency of sulfur is not complete, you have to take 1 electron from here. Are you getting it? This bond here, 1 bond from here and add here, because if you count sulfur valency is this 2, 4, 8, because every 2 electron is 8. So take 1 electron from here to this place. This will give us S double bond oxygen with 2 lone pair of not double bond here. All right, with 2 lone pair of lone pairs of electron like this. Then here will be just 2 lone pair. Now the next thing we need to do is look at that sulfur atom and see if the formal charge on sulfur is 0. Now how do we calculate for the formal charge of sulfur here? If the formal charge is not 0, you know what to do. Now formal charge, we said, is number of valence electrons that sulfur normally had, which is 6, minus the lone pairs of electron. Lone pairs of electron is what? Lone pair of electron here is 2 electrons, so minus 2 electrons, then minus, or we can say plus. If you put this one in bracket, then that plus will affect that minus. That was why I was saying the other time that you have to put it in brackets. Are you getting it? But if you want to do minus minus, it's still fine, but you can just say bracket. Are you getting it? So that you deal with what is inside the bracket and then subtract it according to the laws of mathematics. So this gives us 2. Now the plus half of the total number of electrons that is in the Lewis structure, or total bonds rather, total bonded electrons in sulfur. Now this is 1 bond, this is 2, 3. 3 times 2 is what? 6. So total bonded electron is 6. This time this is 3. Everyone can calculate this by now, which is 6 minus 2 plus 3 is 5. 6 minus 5 is what? Plus 1. It means the charge on sulfur here in this particular structure is plus 1. But what we are looking for is the one in which the charge here is what? 0. Alright? So what we are going to do is to calculate for this one now. To get 0, what did we do? What do? We take one of this one here and place it here, because this electron that is coming will cancel 1 from here. So the structure, new structure that will be formed will be something like this: S, double bond oxygen, double bond what? Oxygen. They will have lone pairs of electrons. Record that 1 is going here, so we have only 2 lone pair here. They will have a lone pair here. They will have 2 lone pairs here. All right. Now let's calculate for this one. Now this one will now be 7 minus lone pair of electron is, I say bracket, 2 plus half of the bond pairs here is 1, 2, 3, 4, which is times bond pair there is how many? Again. Sulfur, is this 7? Did I just calculate 7 for the first one, or 6? Sorry, sulfur is 6 valence electron that is brought in. So 6 minus 2 plus half plus bond pair is 1, 2, 3, 4. When something is wrong, 4 times 2 is 8. When something is wrong, you must always know, so long you know what you are doing. This is plus 4. So 6 minus 2 plus 4 is what? 6. 6 minus 6 is what? 0. So the charge here is what? 0. And this is the correct Lewis structure. Now, my own strategy of teaching is not to go and copy something and come and be telling you here. I love solving it on myself, make mistake, correct ourselves here. All right. So this is the correct Lewis structure of sulfur dioxide. Is that okay? Now let's calculate for that of sulfur trioxide and then see what we can do. That of sulfur trioxide will be, so that of sulfur trioxide will be very easy, which is SO3. Calculate number of electrons first. Sulfur is 6 times 1, which is 6 electron. Oxygen is 6 times 3 oxygen there, 18 electron. Total is 24 electron. Now the structure, of course, everyone knows sulfur will be the central atom because sulfur is less electronegative than oxygen. So we have to subtract these 3 bonds here. 3 bonds, 6 electrons. So we have 24 minus 6 electron, which will now be what? 18 electrons. So the next thing is to complete the octet of the terminal. We already have 2 here, so it means that each of them will be needing 6 each to complete 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 3, we use 3 here. We actually root on 3 oxygen here. So 6 times 3 will give us 18, right? The one we use to fill the terminal. 6 times 3 will be equals to 18. So we subtract 18 electron minus 18 that is left here will be how many? 0 electrons. So no electron to put on the central sulfur atom. Is that okay? Now, since there's no electron to put on the central sulfur atom, what do we do? We now calculate the formal charge on sulfur. To calculate for the formal charge here, is very easy. Number of electrons sulfur brought to the table is 6 minus half of, lone pairs of electron is 0 plus half of, in this structure, what can you say? This is times, our bond pair is 1, 2, 3, right? Which is 6 electron. This cancel this. This gives us 6 minus 3, which equals to what? Plus 3. It means that the charge here on this sulfur atom is plus 3. Alright? Now, we said we cannot, this sulfur compound that is given to your sulfur molecule is not an ion, so we cannot have plus 3 as a charge. The charge must be 0. So what we are going to do now is, I'm going to write the correct one for you. The correct one will be in such a way, you know, for every bond that we are taking to form a double bond here, one of this thing is leaving here to form 2+. So if I take this first one, double bond here it becomes 2+. Take this one here, double bond here, it becomes 1+. Take this one here, double bond. All the plus here is no longer there. So this gives us sulfur double bonded to oxygen, double bonded to oxygen, double bonded to oxygen. Are you getting it now? And then of course you have 2 lone pairs of electrons in each category. Alright, so this is the correct Lewis dot structure of sulfur trioxide that is accepted. Let me calculate this, the formal charge for you so that you know that it's 0. So the formal charge, sulfur is 6 minus oxygen is also, sulfur is 6, that the number of valence electron. Then we have lone pair of electron is 0 plus half of, this is 1, 2, 3, 4, 5, 6. 6 times 2 gives us 12 electrons. Now you can even do this by just counting the number of bonds here, 1, 2, 3, 4, 5, 6. Just include the 6 here without putting the half, because at the end of the day, this time this will also give us 6. Is that okay? So this gives us 6 minus 6, which equals to 0. So this is the correct Lewis dot structure of sulfur dioxide. Alright, and that is the correct answer to that question. So the assignment I'm going to give to you will be this. Now, taking these structures, now what you're going to do as an assignment is to calculate the formal charges of each of the atom labeled A to F. Calculate the formal charge of the oxygen in A. This one B is also oxygen. So you calculate the formal charges of each of the oxygen atom. Alright? Thank you very much for your time. We'll see you in the next lecture. Bye-bye.